Hello guys, today we're going to be talking about adding polynomials. So when we add polynomials, we are trying to look for like terms between each value. Like terms are terms in this type of fashion: 2x plus 19x, 3 plus 5, 12x plus 3x, 8y plus 5y. Unlike terms are terms that are not formatted the same. For example, I can't add 2x plus 2 because this 2 doesn't have any variable next to it, and we don't know the value of this one. The so the answer would be difficult because when it's 2x, you have x. So let's say x is like 2, then this would be 4, and it will completely change the answer. Because let's say another example, this one, right? Let 2x, now we have 2x's and this is x squared. Let's say x is 2 in this scenario, right? You have, and we're trying to equal it to 4, right? Let's say we're equaling this to 4. We would have no idea what this value is going to be, obviously. So then we have to find out what x is going to be before we solve. Now you guys may be thinking, well, there are two variables here. I can add, no, you still can't add this because they have to be the same. When you are facing two problems where the variable is the same, like the rule x, like there's like a rule x equals 1. That applies for both x variables. But in this situation, it would only apply to 1. Unless I write y equals something, I can't solve this. So this is one where unlike terms are not solvable. All right, next one. Let's find the sum of these two equations. Y squared minus 2y plus 9 plus 4y squared minus 8y minus 7. Already in the beginning, we noticed that I see a lot of like terms, right? 7y squared, y squared, y squared, y single, right? We have to rewrite each polynomial in standard form. If you guys don't know what standard form is, you're looking straight at it. Look for the like terms between two polynomials. We just did that. Now let's combine like terms by adding coefficients. Coefficients are literally the numbers you see right here. So let's add it. 7y squared plus 4y, that is 11y squared. Negative 2y plus negative 8y, that is negative 10y. And then 9 plus negative 7 is positive 2. This would be our final answer. So what did we do first? We went with this. This is step 2. And this is step 3. All right. To stack it, if you guys want to stack and solve it, it would look like this. So 7y squared minus 2y. And you guys see how I'm really spacing out my digits here. Because when you're doing stacking, you don't want to get confused. That's the last thing you want to happen. So 4y squared minus 8y minus 7. Now, one thing you want to notice is there's no sign before this. It's only a parenthesis. Same here. There's no sign. Whenever there's no sign, always assume it's a positive number. Unless there is a specific sign dedicated to it showing it's negative, it's never negative. Okay, some people do get confused with that. So 7. So again, we're doing it 7 plus 4, 11, y squared minus negative plus negative. That becomes 10y. Sorry, I lagged for a sec. And then 9 plus negative 7, that is negative 2. That is problem number 1, how you solve. Okay, for this one, we need to find the sum. 3x plus 7, x squared minus 6x plus 4. Right? There's a problem. You want to know what it is? I don't see it. I don't see an x. I see x squared and then I see a 7. I don't know what to do. I can't stack this. You still can stack this because all we have to do in this situation is use 0 as a placeholder. It's like when you're doing double digit multiplication, you add like a placeholder of 0. Same thing you do here. So you're gonna write each polynomial in standard form. Well, yeah, it's standard. Like terms, x squared, none, none, right? We don't worry about this digit because when we add that 0 as a placeholder, this is okay. So now let's go. We have 3x squared plus 0x plus 7. Now 0x isn't really a number, so you could also just write 0. For the demonstration sake, I am going to write 0x. So then we have x squared minus 6x plus 4. Now let's do the addition, shall we? We have 3x squared plus x squared. That becomes 4x squared. We have 0x plus negative 6x, which becomes negative 6x. That just carries. And we have 7 plus 4, which is plus 11. And this would be your final answer. Now we're going to get to subtracting. It's the same principle as adding. You're doing the exact opposite. So let's go ahead and get into these problems. But before we do that, I want to quickly go and solve a quick example and show you guys what I'm talking about. So we have 2x plus 4y minus 3x minus 2y. The steps for this are really, really simple, actually, because you won't be adding, you won't be subtracting anything. I know, very, very surprising. You won't be subtracting anything. Instead, what you'll be doing is you will be adding. Watch. With this negative symbol, I can consider a -1, almost, right? So then I multiply -1 to this and to this using the distributive property. So I can make this 2x plus 4y plus plus -3x plus 2y. Now I'm not gonna stack it for lack of room, but you get the idea now. Since you now have this, you can now do it easier. So now you have -x, right? And then you have plus 6y. Because 4y plus 2y is 6y. And you're also adding. So basically the steps you're going to do is you're going to find the problem if it's subtracting. You're going to multiply the second half of the problem by -1. And then and it should turn completely positive, and you'll just be adding polynomials again. So it's that one extra step you're going to have to do if you're going to make it a addition problem. Because that's what we want to do. We want to start adding. We want to only add polynomials. We don't want to subtract, because subtracting can get real messy. So let's go ahead and write this out. First, let's follow the steps. Rewrite each polynomial in standard form. Lovely. It's in standard form for us. Rewrite subtraction as addition of the opposite. So now what I could do is I can multiply this entire thing by -1. That is another plan, but it would be a little bit more difficult. So I'm just going to do only 1/2. Let's do 9b squared minus 5b minus 4. Right, we're going to leave this alone. We don't touch this. This one, I'm going to insert a little 1 here, and I'm going to distribute this -1 to 3 different digits. So now this becomes plus -3b squared plus 5b plus 7. Now we're gonna add it. So 9b squared plus -3b squared. That is 6b squared. Okay, good. -5b plus +5b. Well, that's 0, so I don't have to write anything. -4 plus +7. That is +3. So my final answer is 6b squared plus 3. Let's go to the final problem. Let's subtract 4h squared plus 3h minus 9 minus h squared plus 5. So immediately, write each polynomial in standard form. Well, lucky for us, it's in standard form. We are each subtraction to addition, so we're going to do this. And then we're going to go distribute the problem like this. So now it becomes 4h squared plus 3h minus 9 into plus negative h squared plus, sorry, negative h squared minus 5. And remember, we are also going to be using a 0 as a placeholder. So if you want, you can also write it as positive negative h squared plus 0h minus 5. But again, it's completely up to you how you want to write this, because then we can slowly mask it down. So I'm going to underline. We have 4h squared and plus negative h squared. That becomes 3h squared. Step 1 complete. Next one's going to be in pink. Sorry, purple. positive 3h plus 0h becomes plus 3h. For our last one, we're going to do this in black. -9 plus +5. Sorry, -9 plus -5. My bad. That becomes -13. Hold on, wait. I'm sorry, -14. This would be your final This would be your final answer for this problem. Hopefully you guys learned something about adding and subtracting polynomials. Make sure you guys like and subscribe to the Tops Tutoring YouTube channel. We will always upload once a week all your algebra concept needs. Thank you.